So section 3.3, if you have just the matrices and the inverse, and we already did that in the previous class. If A is an n times n matrix, the inverse of the matrix is going to be A. This is not exponents. Okay, from now, sometimes you're going to see only A and there's a dash. That means this is the inverse, okay? Or -1. There is no -2. There is no -3, okay? Just A is a matrix. And if it's -1, that means this is the inverse of the matrix A. If you multiply the matrix A with the inverse, the result is going to be the identity matrix. For example, the identity matrix for 2 times 2 is 1, 0, 0, 1. This is the identity matrix with size 2 times 2. A invertible matrix. What does that mean? The next theorem. They're going to tell you if A invertible matrix, that means there is inverse for the matrix. So this is really important as a theorem. They're not going to tell you here's the matrix A or here's the inverse for matrix A. No, they're going to tell you A invertible. What does that mean? Its inverse is unique. That means there is an inverse, and the inverse is unique. One inverse, not more than one inverse. No, it's one inverse for the matrix, and it's unique. And they're going to tell you it's invertible. Okay. Now a system. AX equal B. This is a system. You're going to write down a matrix A, X equal B. Has unique solution. This is another way to find the solution for the matrix. You're going to find the inverse for the matrix, and you're going to multiply by B. You're going to get X, which is the solution. So this is another way to solve the system. Find the inverse for the matrix times B. The result is going to be the solution, okay? So here's another method. If they ask you, like on the test, if they give you a system and they ask you to find the solution, it's up to you. You want to reduce the matrix and solve the system, or you want to find the inverse and multiply by the matrix B, you're going to get the solution. Because they're not going to give you the way to find the solution, okay? This is the method we learn about how to find the inverse when it's 2 times 2 matrix. So for A, B, C, D has inverse if the determinant not equal 0. Again, how to find the determinant? You're going to multiply A times B, D minus B times C. Find 0. So here's the determinant. It's supposed to be not equal to the 0. A times D minus B times C not equal 0. That's mean there is inverse for the matrix. If it's equal 0, that means there is no inverse. And here's the inverse going to be 1. Divide by the determinant of A. You're going to switch A and D, change the sign for B and C. Multiply, this one is going to be a scalar, times the matrix is going to be the inverse. This is exactly what we did on the previous class. So the first thing, I'm going to check the determinant for the matrix, which is equal 1 times 4 minus 2 times 3. And it's going to be 4 minus 6 is going to be -2. Not equal 0, that means there is inverse for the matrix. In this case, the inverse for the matrix is going to be 1 over the determinant, which is -2, times, switch these two numbers A and D, so 4, and here's 1. Change the sign here, which is -2, -3, and then it's going to be -1 over 2 times, let's multiply right away. That's mean 4 divided by -2 is going to be -2. -2 by -2 is going to be 1. -3 over 2 going to be positive, and -1 over 2. This is the inverse for the matrix A. How are you going to check that? If you multiply the inverse times the matrix A, the result is going to be the identity matrix. To check that, if you multiply A times the inverse, the result is going to be the identity, which is equal 1001. Okay? Some properties about the inverse. These are also important, especially this one. You already know that the inverse of the inverse is going to be, go back to the original matrix, the inverse of the inverse. So if you have this inverse, here's the inverse of the matrix A. If you take in the inverse for it, you're going to go back to here. Okay? Of course, these properties of theorem, you're going to use it when you prove, because there's a proof for each one. The scalar times the matrix A inverse is going to be 1 over C times the inverse of the matrix A. Okay? This is what we're going to use. A times B inverse is going to be B inverse times A inverse. These are two equal sides. A times B inverse is going to be B inverse times A inverse. The transpose inverse is going to be the same thing, the inverse transpose. So if you take in a matrix and you take the transpose for this matrix, then you can take the inverse, it's going to be exactly the same result. If you take in the inverse for the matrix and take then the transpose. So this side is going to be equal. With the power, it's going to be the last one. If you have A to the power 5, what are you going to do? A to the power 5 inverse is going to be the same thing, A inverse to the power 5. Again, there is a proof for each one. You can use the one. Any questions so far? Before we jump in to the next part, which is important part. Elementary matrices. So the elementary matrices, again, you have to practice about how we're going to find the elementary matrices. First of all, what I'm going to do, I need to convert the matrix A to the identity matrix. So my goal is to convert this matrix to the identity matrix. Okay? That means I need to do some row operation on this one. On the matrix, not the identity. 1, 0, 0, 1. Okay? The identity matrix. That means I'm going to do some row operation on this matrix to convert it to the identity matrix. So this is our goal, which is the identity matrix. So I'm going to write down the matrix A. 2, 3, 1, 3. So if you look to this matrix, what's the first thing I need to convert to 1? I'm going to start with this one to convert it to 1. But if you look to this matrix, if I switch row 1 with R2, the first leading integer is going to be 1. So instead of dividing, and we're going to get a fraction here. So what I'm going to do, switch row 1 with R2. So this is the first operation. I'm going to say R1, change it with R2. So the new matrix is going to be 1, 3, and 2, 3. I'm going to do, here is the new matrix, 1, 3, 2, 3. Let's do the second operation. So you can know I'm doing these because this is a matrix by itself. This is going to be a matrix. Each operation you're going to do for the new matrix is going to be elementary matrices, okay? You're going to check it out. Now, what's the next step? Here's my new matrix. The first leading entry is 1. Now, this number here is supposed to be 0. So what I'm going to do, I'm going to say the new R2 is going to be multiply R1 by -2 and add it to the 2. Multiply R1 by -2 and add it to the R2. Okay? So if I do this operation, -2 times 1 is going to be -2 plus 2 is going to be 0. So my second matrix Here is the first row. The second row is going to be -2 times 1, -2 plus 2 is going to be 0. -2 times 3, -6. -6 plus 3 is going to be -3. I'm done from the second operation. The third one. What's the third operation?
You need to convert number 3.
So it's -3. So here is the new matrix. So if you look here, you want to convert this one or you want to convert this one? Which element you want to both is going to be right. So here is my third matrix.
We want
1 and 3, 0, -3. If you said I'm gonna add R1 to R2 is going to be right, this number is going to be 0. Okay, but I always start from this one, this one, this one, and go back here. So now I need to convert this number to 1. How are we gonna convert it to 1? We're gonna divide it by. So R2, I'm gonna say -3. R2, I'm gonna divide it by -3. Check what's gonna go. That means it's going to be 1, 3, and here is 0, and here is 1. That's okay, that's right. The next step is to convert this number to
0.
0. So 1, 3, 0, 1. How I'm gonna convert it? I'm gonna multiply R2 by -3 and add it to R1. That means the new R1 is going to be -3 times R2 plus R1. The result is going to be 1, 0, 0, 1. We already know how to do these steps. My goal is to find what it says on the top. Elementary matrices. In fact, what you did, these steps, you did elementary matrices. You multiply the matrix A by elementary matrix to get this matrix. You multiply the new matrix by elementary matrix to get this one. You multiply the new matrix by elementary matrix to get this one. This here, the operation is a matrix, is elementary matrix. Let's write down these elementary matrices. Four elementary matrices. The first one, that's why I did this one step by step. This is the first matrix. This is the second one. This is the third one. And here is the fourth one. Let's check that. Elementary matrix, we're gonna say E, okay? Anytime when you see E, E1, E2, E3, that means this is elementary matrix. Let's write down the first matrix, E1. Always, I'm going to start using the identity matrix. I know my identity matrix is 1, 0, 0, 1. Now, I'm going to find the first elementary matrix. The first elementary matrix. What I did here, I'm going to do here. What's the first operation I did? I changed row 1 with R2, right? So what I'm going to do here, I'm going to change R1 with R2. That means it's going to be 0, 1, 1, 0. Okay, this is the first elementary matrix. Now let's check the second one, E2, which is here. E2 is going to be which row I worked on E2? which number I need to convert it.
Change R2.
Oh, you change which number here? 0, which number?
The 3. No.
Which is
The 2.
the 2. We convert the 2 to 0. That means, what's the number here? -2. I'm gonna write down -2 here, exactly instead of this number. I'm gonna write it down here. The rest, I'm gonna go back here. It's 1, 0, and 1. I'm working on this matrix. You see, I'm not gonna look here. Here is the identity matrix, right? I'm gonna write down the identity matrix. 1, 0, 0, 1. This is the identity matrix. Now let's look to this number. Which number I worked on the second one? I worked on this number. I need to convert this number to 0. So here's the operation, -2. So I'm gonna write down here, instead of the 0, -2. You got it? Everything's okay? This is the second elementary matrix. Now, what about the third one? Which, be careful, it's a division. Which number I work to? So if you multiply, you're gonna write down exactly the same number. Here's multiplication, right? Here's multiplication, here's the switch. Here's division. You're not gonna change the number. You're gonna write down exactly the same number because you divide -3 by -3. So I'm gonna write down, here's E3. One, 0, 0, 1. Which location? Here. What's the number you have here? What I'm gonna write down here? It's a division.
Your third.
You're not gonna write down. 1 is the identity matrix. What are you gonna write down here? It's you divide it by -3, okay? So here it's multiplication. I'm gonna write down the same number. Here division. What I'm gonna write down here?
The inverse.
What's the inverse? Here it's 1 over -3. What's the inverse of it? It's 1 over -3.
Oh.
Okay. Now tell me the next one. E4. I'm gonna go back to the operations. Okay. This is okay. This is okay from this one. Okay. So this is the new matrix. Now, if I add this one with this one, it's gonna be 0. That's mean R1 is going to be R2 of R1 plus R2. If you 3 minus 3 is going to be 0. So that's what I'm gonna do. Let's check this operation. So it'll be 1, 0, and this one is going to be 0, and this one is going to be -3. Okay. Now let's write down the new matrix. 1, 0, 0, -3. Now the last operation, we need to convert this number to 1. So I'm going to divide by R2 is going to be here. Going to be R2 divided by -3. R2 divided by -3. The result is going to be 1, 0, 0, 1. Let's go back here. This is okay. This is okay. The third one and the fourth one. Which number you worked on? This number in this location, right? To convert it to 0. What's the number here? 1. I'm gonna write down 1 here. Okay, and what's the number here is going to be also 1 because we're gonna work with the identity matrix. 1, 0, 0, 1. I'm gonna change only the 0 here to 1. What about the next one? I'm gonna work with this number here. So it's a division. So I'm gonna write down here 0, and here what I'm gonna write down -1/3. Now go ahead. If you multiply E4 times E3 times E2 times E1 times A, how much is the result?
Two. Ten. Put it the way around. Then that you want.
So you have to from here E4 times E3 times E2 E1. That's mean when I did these 4 operations on the matrix A, what's the result? The identity. That's mean each operation here is a matrix. We multiply the matrix A by E1, you see, we're gonna get this matrix. Then we multiply the result from here by E2, which is this operation, we can get the new matrix. Multiply the result of EA, E1, E2 by E3, we're gonna get this matrix. And multiply the result from A, E1, E2, E3 by E4, the result is going to be the identity matrix. So now let's look. For this part here, E1, E3, by the way, this is 2 times 2 matrix. That means how many elementary matrices we have? We have 1, 2, 3, 4. If it's a 3 times 3, sometimes you're gonna get 7 elementary matrices. With the next example we're gonna do, okay? So I'm gonna go back to this. So if I'm going to find E1 inverse, E1 inverse for this matrix. The inverse for this matrix is going to be the same one, 1, 0, 0, 1. No, it's 0, 1, 1, 0. We're going to change anything, okay? Talking about the inverse, that means if you use this method here, for this matrix, the result is going to be this one. I'm going to tell you an easy way to find 2 times 2 matrix, what I'm going to do. What about if I need to find E2 inverse? What's the result? Check 1, 0, here's 1. This number is going to be positive. So the E inverse is going to be 1, 0. This one is going to be positive, and keep this one as a 1. So this is the inverse for this matrix. Okay. What about E3? It's going to be what? This number we work on, right? So 1, 0, this one is going to be -1, and here is 1. The last one, E4 inverse, is going to be 1, 0, 0. Careful, no. That's the confusion here. 1, 0, 0, and this number is going to be -3. Because it's division, okay? So when you have numbers on the diagonal, always when you need to find the inverse, you're just gonna write down exactly the reciprocal for this number, but you're not gonna change the sign, okay? But for this one, not the diagonal element, you're just gonna change the sign from negative to positive, from positive to negative, positive number to negative number. So these are the inverse for the elementary matrix. Check now what we're gonna get. If I'm taking the inverse on the top, Because if I multiply E4 by E3, E2, E1, and matrix A, the result is going to be the identity, right? If I take the inverse for both sides, if I'm taking the inverse for both sides, okay, that means if I need to find the matrix A, here's the elementary matrices. So if I multiply both sides by the elementary matrices, if I need to find the matrix A, it's going to be E4, E3, E2, E1, inverse. That's mean A goes with the identity. A is going to be I'm gonna multiply. Let's check that. E1 inverse, E2 inverse, E3 inverse, E4 inverse. So if you multiply the inverses for these matrices, that's mean what are we gonna do? If you do the times I, if you say I, which is this one, times E1, E2, E3, E4, the result's supposed to be the A matrix. So go ahead, do that. Multiply the inverse, the identity matrix times E1 inverse, E2 inverse, E3 inverse.
1, 3, 2, 3 on that. The inverse or the one over there.
The first thing we're going to use Gauss-Jordan method to find the inverse for this matrix, okay? I'm gonna show you the method because we're gonna use the raw operation method to find the inverse. But on the same time, when we finish from this example, we're going to try to write down the elementary matrices. Because it's the same what we did on the previous example. So Gauss-Jordan method, he said, okay, what about if I write down the matrix A with the identity matrix and try to do this operation on both on the same time? I'm going to convert this matrix to identity. What's going to be the result on this side? So just combine everything. This person, he came and said, okay, what if I said, okay, here's my matrix. I'm going to say 1, 0, 0 here, 0, 1, 0, 0, 0, 1. Okay, I'm going to do this. Here's my matrix A, and here is the identity. So what I'm going to do, I'm going to convert this matrix to the identity. But when I'm do any raw operation on this one, I'm going to do the same raw operation on the identity. This one is going to be the identity. What that mean is going to be the result here? It's going to be the inverse. So that's what he's going to do. He said, okay, I'm going to do 4, going to be more than 1, 4, but we're going to do 2 on the same time, okay? So the first one, we're going to convert. It's already 1. The first number is already 1. So I need to convert this number and this number to zeros. So I'm going to do 2 operations on the same time. I'm going to say R2. This number, if I need to convert it to 0, I'm going to multiply -2 and add. So I'm going to say -2 times R1 plus R2.
So we're finding the row echelon form. Is that what this is technically?
Technically, yeah, the same techniques, but now we need to find the inverse.
Okay.
Because this section, our goal is to find the inverse. But on the same time, they're telling you when you do these here, the rules, it's some matrix. Exactly what we did on the previous example. So each steps here, it's a matrix by itself, it's an elementary matrix, okay? You're gonna multiply the elementary matrix by the identity matrix to get the new matrix here. Okay, so but now our goal is to find the inverse for the matrix. So you're gonna write down the matrix, you're gonna write down the identity matrix, you're gonna do the row operations by converting this matrix to the identity. The new matrix here is going to be the inverse. Okay, so that's our goal. So the first row is going to be the same, yes or no? That means it's going to be 1, 2, -1, and here is going to be 1, 0, 0. Now, let's check the next one. This one is going to be 0. Now, -2 times 2 is going to be -4. Plus 2 is going to be -2. -2 times -1 is going to be 2. 2 plus 4, 6. Keep going. -2 times 1, -2. Plus 0, will be -2. -2 times plus 1, going to be still 1. And -2 times 0, -2 plus 0 is going to be 0. So I'm done from the first, convert this element to 0. Check what happened here. Check what happened here. 2 converted to which number?
Negative.
To -2. You got it? So the inverse for 2 is what? -2. If you go back here, the inverse for -2 is what? 2. You got it? So it's the same thing, but now we're doing to find the inverse for 2 is -2. We have to keep going. Now, what's the next step? Convert the 1 to what?
Zero.
To 0 here. And it's going to be what here? It's going to be -1. Let's check that. Let's check. So I need to convert this number to -1. So I'm going to say R3 is going to be -1 times R1 plus R3. Yes or no? -1 times 1 is going to be -1 plus 1, 0. -1 times 2 is going to be -2 plus 3. That one. -2 times -1 is going to be 1. 1 plus -3. -2, yes or no?
Yes.
-1 times 1, -1 plus 0, -1. -1 times plus still 0. -1, so here's still 1. Check the new matrix. So how many elementary matrices here?
2.
2 elementary matrices, okay? 2 elementary matrices because I did 2 steps on the same time to compare this number and this number. Now the new matrix is going to be this one. Now tell me, I'm not going to look here anymore. This is my new matrix. Now let's check. What's the next number I have to work on? The zeros, this is what?
-2
I have to convert -2 to what?
to 1.
To 1. So what I'm going to do, I'm going to say R2 is going to be the old one, divide by -2. Okay. That's mean R1 and R3 is going to be the same, which is 1, 2, -1, 1, 0, 0. And R3 is going to be the same. -1, 0, 1. Now tell me, what's the number is going to be here? Let's check. Remember when we have -1/3 became what? -3. What about if you have -3? No. No, it's, I told you on the diagonal is going to be the reciprocal. On the diagonal row is going to be the reciprocal. So -1/3 is going to be -3. -3 is going to be what? -1/3. So if I have -2 here, is that the diagonal? What's the result is going to be here or here?
Half.
-1/2. Let's check that. So I'm gonna divide by -2. 0, this is 0. -2 divided by -2, 1. 6 divided by -2, -3. -2 divided by -2, 1. 1 divided by -2, -1/2. And this is 0. You got it? It's more clear now what we're doing. We multiply this matrix by elementary matrix to get this one. Okay? Now let's write down our new matrix. Tell me the numbers. 1, 2, -1,
1, 0, 0, 1.
0, 0, and 1, -1/2, no, 1, -3, and here 1, -1/2, and 0, 0, 1, -2, and -1, 0, 1.
Professor, the first number on the second row is supposed to be a 0.
Which one?
First number on the second.
Oh, yeah, good. Yeah, always tell me because sometimes when I'm copying the numbers, I do mistakes. Okay, everything is right now. Okay. Now, which one we have to convert to zeros? 2 and 1. I'm gonna do again 2 operations on the same time. R1, convert this one. I'm gonna multiply R2 by -2 and add it here. Let's check that out. This is gonna be the same. 1, 0, 0. And here is 1, -3, 1, -1/2. Because there will be change on the second row. So -2 times 1, -2. Add to the 2 is going to be 0. -2 times -3, is going to be 6. -1, 5. -2 times 1 is going to be -2. +1, -1. -2 times -1/2. -2 times -1/2 is going to be 1. 1 plus 0 will be 1. -2 times a plus is going to be 0. We're done from this one. We convert this number to 0, and here is the new row. Is that okay? Next step, convert the 1 to 0. So I'm going to say R3. I'm going to multiply this one by the opposite sign. So by -1 times R2 plus R3. 1 over the 0. -1 times 1 plus 1 is going to be 0. -1 times -3 is going to be 3. -2. 1. Now -1 times 1 is going to be -1. -1, -2. -1 times half going to be half. Plus 0. Here we get half. -1 times 0 plus 1 is going to be 1. Perfect, get the zeros here, because it's already one, so I don't need to divide it by one. This number is already one, so I need to convert these two numbers to zeros. We're gonna do two steps on the same time. Here's going to be the result. It's the inverse. So 1 0 0, no change here. And here is 0 1 0. And this one is gonna be still the same. So our goal is to convert this number to 0. That means I need to use this rule. I'm gonna say R2 is going to be 3 times R3 plus R2. So here. So 3 times 1 is going to be 3 plus 0. Let's write down here, -2 half and 1. Now 3 times -2 going to be -6. -6 plus 1, -5. And 3 times 3 times half is going to be 3 over 2. 3 over 2 minus half is going to be 2 over 2, which is 1. So here is 1. 3 times 1 plus 0 is going to be 3. Last operation, we need to convert this number to 0. So I'm going to say R1 is going to be -5 times R3 plus R1. So it's 5, so I'm going to put -1. So -5 times 1 plus 5 is going to be 0. -5 times -2 is going to be 10 minus 1, 9. -5 times half, so -5 over 2. -5 over 2, or plus 1. That's be a plus 1 is 2 over 2. So it's going to be -3 over 2. -5 times 1, -5, plus 0, -5. Is that the identity? What's that mean? This is the inverse. This is the identity matrix. Okay, we can write down n for this 3 times 3. I3. So let's look. To find E1, what I'm going to do. Check, let's go back here to the first operation. What's the first operation here? Right? In which number? On this one, right? We need to convert this number to 0. What I have here? -2. So I'm going to say I'm going to change this number here to what?
2.
-2. So this is the third elementary matrix. You see what we did here? -2. I'm gonna change. Here's my identity matrix. I'm gonna change this number here to -2. Okay? Now, can we find E2? E2, tell me E2. Here is the identity. Is that the element here? On this location? Look to the second operation. What number we have? -1. So I'm going to change this number to. So 1 0 0 0 1 0 -1 0 0. Yes or no? Is that hard? That's E two.
The last number is still one now, or no?
Oh, it's one. Yes, tell me. Sorry. Because the identity. So it's one, okay? Now E three. Which number we have to work on? This number, right?
Yeah.
Which is here. So it's a division. Be careful. You take the reciprocal. 1 0 0 0 0 0 1. What I'm gonna put here. Focus the diagonal. You're gonna take the reciprocal for the number. I have negative 1 over negative 2. What I'm gonna put here?
2.
Just the reciprocal. Not the opposite. Negative 1 over 2, the reciprocal is negative 2. What's the operation here? Here's the elementary matrices. These, what he did here. So
Okay.
1 over negative 2, the reciprocal is negative 2. Okay? E4. Which number we work on? E4 over there. Here, right? I have negative 2, so I'm gonna write down negative 2. Here, right? 1, negative 2, 0, 0, 1, 0, 0, 0, 1. Yes or no? E.
Bottom 0.
Middle bottom, which is here. This one is going to be what? Negative 1. So 1 0 0 0 1 0 0 is going to be negative 1 and 1. What about E6? Which one E6? This one, right? So which number we worked on? Negative 3. So negative 3 became 3. Which is, so it's gonna be 1 0 0 0 1 3. Yes or no? The last one E. 7 is going to be which number we working on? E7, negative 5, which is the number here. So I'm gonna put negative 5 where?
Right.
So if you multiply E7, E3, E2, E1, and go back until multiply by A, the result is going to be the identity matrix. That means here, if you said E7 times E6 times E5 times E4, E3, E2, E1 times A, the result is, which is the identity, this one. Now, let's do the inverse. E1 inverse. Check. You're just gonna take the reciprocal if it's diagonal, okay? Here's the identity, this number. What's the inverse for it? Negative 2 became 2. So this is the inverse for E1. Check this number, negative 2 became 1. So now E2.
Professor, the inverse for anything that's not on the diagonal is just the opposite sign?
The opposite sign if the element not a diagonal, okay? But this is, be careful, this is only for the elementary matrices. If it doesn't mean if I do the inverse for this one, I'm gonna change these numbers and the diagonal take the reciprocal. No, it's going to be wrong. Okay, this is only for the elementary matrix. Is that elementary matrix? Yes, because it's not gonna change anything. Why? Because here is an identity. Only this number, I'm gonna change it. Okay? So E2. Check the numbers. Here's the diagonal. So this one is became 1. 0, 1, 0, 1, 0, 1, 0, 0. Now E3. Check E3 1.
Negative half.
So it's gonna be the reciprocal for this one is going to be negative half. That's mean 1, 0, 0, 0, negative 1 over 2, 0, and 0, 0, 1. You do the same thing for E4. So be careful, we did the mistakes here. The operation is exactly the same thing. So if it's negative 1 over 2, the elementary operation is going to be negative 1 over 2. Okay? But when you take in the inverse, for this one, it's a diagonal, so it's going to be negative 2. The reciprocal for this one. Now E4. E4 inverse. This is the inverse. E4 inverse is going to be just this number became 2. So this is 1, 2, 0, 0, 1, 0, 0, 0, 1. And the same thing for E inverse to the 5. Negative 1, I'm going to change negative 1 to 1, 0, 0, 0, 1, 0, 0, 1, 1. This is E5, E5 inverse. E6. E6. So you see E6 inverse 3. I'm going to change it to negative 3. 1, 0, 0, 0, 1, negative 3, 0, 0, 1. The last one, E inverse 7. Instead of negative 5 is 5. Yeah. When you write down the elementary matrices, you're not going to change anything here. Write down exactly the same thing. Like negative 2, we're going to write down negative 2. 1, negative 1, check the second operation, negative 1, I'm going to write down negative 1. Divide by 2, that's mean negative 1 divided by 2, okay? But when I write down the inverse, I'm going to be careful about which element. I'm going to be careful about the diagonal. When I write down the inverse, only the diagonal, I'm going to take the reciprocal. The other elements here, I'm going to change just the sign. From negative 2 to 2. Negative 1 to 1. This is diagonal. It's going to be negative 2, the reciprocal. This is not a diagonal. Negative 2 changes to 2. Negative 1 changes to 1. Okay? For the 6, it's a 3. I'm going to change it to negative 3. For the 7, E7, negative 5, change it to 5. Now, one more thing. Is that mean the matrix A is going to be the identity times E1 inverse, E2 inverse, E3 inverse, E4 inverse, E5 inverse, E6 inverse, E7 inverse. That's mean if you multiply the identity times all these matrices, which is the inverse, the result is supposed to be the matrix A.